students, welcome to Sunil's tutorial. I'm Sunil Manwani and today we'll be doing this chapter called as circulation. Let's see the process of clotting of blood. Clotting of blood. How does clotting of blood take place? Clotting of blood is also called as coagulation of blood. Also called as coagulation. So in the exam, whether they ask you clotting of blood or coagulation of blood, it is the same thing. Fine. Now, how does clotting take place? Now, whenever there is an injury, the platelets from the injured tissue release something called as thromboplastins. Right? So the first step is if you have injury, you have injured platelets, they will release something called as thromboplastin. Right? So the injured side releases thromboplastin. What does thromboplastin do? Thromboplastin, this is my first step in clotting of blood. Right? What will thromboplastin do? Thromboplastin initiates the formation of an enzyme which is called as prothrombokinase. Thromboplastin, second step, thromboplastin initiate the formation of an enzyme which is called as prothrombokinase. Right? Now, the enzyme prothrombinase, what does it do? It converts inactive prothrombin into active prothrombin in the presence of calcium ion. What does this enzyme do? You have prothrombin which is inactive, right? Because of this enzyme prothrombinase and in the presence of calcium ions, the prothrombin will get converted into thrombin active. So it converts the inactive prothrombin into active thrombin, right? Now this thrombin acts as solid protein fibrogen of plasma which converts it into insoluble fiber. See, what will this do? You have fibrinogen, soluble. The fibrinogen that is present in plasma is soluble. Because of this active thrombin, the soluble protein fibrinogen which is present in the plasma gets converted into insoluble fibrin. This gets converted into fibrin. It's again a protein compound, but the difference is instead of being soluble, it is insoluble in plasma. Right? Now, it is this, the injured cells, that is your blood cells, plus fibrin, which is my network of proteins which is intermingled with each other, give rise to clot. So that's how clotting of blood takes place. Let's go through this once again. So when there is an injury, that is your blood cells would release, the platelets from the blood cells would release thromboplastins. Thromboplastin would initiate the formation of an enzyme called as prothrombinase, right? This enzyme would convert inactive prothrombin into active thrombin in the presence of calcium ions, right? Now the thrombin so produced, what will it do? It will convert the soluble protein fibrinogen in plasma into insoluble fibrin. and this insoluble fibrin reacts with the blood cells to form clot. Let's just write this down. Let's write the process down. When there is an injury, the platelets from injured tissue release thromboplastin. That's the first step, right? So whenever there is an injury, the first thing that you'll have is thromboplastin will be released, right? Thromboplastin initiates the formation of enzyme, prothrombinase, right? Now the third step, first you will have thromboplastin, then that will give rise to prothrombinase. The prothrombinase will convert the enzyme prothrombinase converts inactive prothrombin into active thrombin. Right? In the presence of calcium ion. Right? Next, the thrombin acts as solid protein fibrinogen. Thrombin acts as solid protein fibrinogen of plasma, thrombin acts on solid protein fibrinogen of plasma and converts it into insoluble fibrin. Right? These fibrin fibers form network in which the platelets blood cells and worn out tissues get entangled to form the clot. That's how clotting of blood takes place, which is also called as coagulation of blood. Right? Next, let's see something else. Let's see what is the cardiac output from the heart. The next thing that we will see is what is the cardiac output. We know that heart beats 72 times per minute, and let's see how much blood does it give out. Cardiac output. Now, during each heartbeat, the ventricles pump 70 ml of blood. 70 ml of blood is pumped during each heartbeat. This is called as stroke volume. This amount of blood is called as stroke volume. So we know that the heart beats 72 times per minute. With each beat 70 ml of blood, So 70 into 72, that would give you,
5040.
yes, that would give you 5040 ml of blood in a minute. And this amount of blood is called as cardiac output. That is the amount of blood that is pumped by the heart in 1 minute. Right? Do we get this in here?
So it increases during exercise?
Yes, it increases during exercise. This is my normal, I'm telling you. Right? Again, it's when you are in period of rest, it decreases. But that's my average. Okay? So I can say that during each heartbeat, ventricles pump 70 ml of blood. 70 ml of blood. This is called stroke volume. This amount of blood is called as stroke volume. Right? The heart pumps about 72 times in minute. Stroke volume is 70 ml. That's 5040 ml of blood in a minute. Right? And this is called cardiac output. So your cardiac output is going to be 5040 ml of blood. Fine, do we get this in here? Next, let's see something else. Let's see an anomaly in heart. What do you mean by what do I understand by angina pectoris? Now, angina pectoris is the biological name for a pain in the chest. Right? Why do you have a pain in your chest? It results from a blocked or hardened coronary artery, which is caused by arteriosclerosis, leading to insufficient blood supply to the heart muscle. So when you have insufficient supply to the heart muscle, you would have a pain in your chest. During stress or exertion, the heart requires more oxygen, but because of the narrowed blood vessel, it cannot supply that extra amount of oxygen to the heart, which due to which the heart muscle experiences a constricting pain, and that is what is your angina pectoris. Fine, do we get this in here? Angina pectoris is characterized by heaviness and severe pain in the heart or chest. The pain can also be felt in the neck, shoulder and the lower jaw. Right? It is not a fatal condition and can be relieved with some medicines. However, pain due to this condition gives you a warning of heart attack. Once you have angina pectoris, that later develops in the advanced stages, goes on to develop heart attack. Right? So do we understand what is angina pectoris? So angina pectoris means pain in the chest. Right? It results from the blocked. It results from blocked or hardened coronary artery. I had already explained this to you that hardening of coronary artery takes place due to arteriosclerosis, right? Leading to insufficient blood supply to heart muscle. Right? Now, when does this occur? This would occur normally when you are in a period of relaxation. This will not occur. It's only when you are under stress, when the heart requires more oxygen, and the coronary artery is blocked, it is at that point of time that you will experience this pain. So you can write this: during stress or exertion, during stress or exertion, heart requires more oxygen. Heart requires more oxygen, but these narrowed blood vessels cannot supply it. And the heart muscles experiences a constricting pain, and the heart muscle experience a constricting pain, which is called as angina pectoris, right? Now, what are the characteristics of angina pectoris? It is characterized by heaviness and severe pain in the chest, and severe pain in chest, right? The pain can also be felt in neck, shoulder. Pain can also be felt in neck, shoulder. Pain can also be felt in neck, shoulder, and lower jaw. Fine. It is not always a fatal condition and can be relieved with some medicines. It is not always a fatal condition and can be relieved with medicines. However, pain due to this condition gives a warning of heart attack. Pain due to this condition gives a warning of heart attack. Right? So that was my angina pectoris, right? Next, let's see something else now. What do I understand by electrocardiogram, ECG, which is also called as ECG? Electrocardiogram. What is electrocardiogram? Electrocardiogram is the record of the electrical events of the heart during a cardiac cycle made on the graph paper in the waveform. As I told you that the heart is myogenic. Since the heart is myogenic, the beating of the heart takes place due to electrical impulses produced in the heart. Now if you record those electrical impulses on a paper, graph paper, then that is called as your electrocardiogram. Right? So what is electrocardiogram? Is the record. It is the record of the electrical events. It is the record of the electrical events of heart occurring during cardiac cycle, made on a graph paper, made paper in waveform. Right? Electrocardiogram is short form is ECG. Right? Do you hear this thing here? Now, why do I need to get an electrocardiogram? It is useful to detect abnormal functioning of the heart, like hypertension, rheumatic heart, congenital heart defects, effects of certain drug on heart, cardiac arrest, coronary artery diseases, heart block, angina pectoris. So all this can be easily detected with the help of electrocardiograph. So why do I use it? It is useful to detect abnormal functioning of heart. Right? And it also indicates the rate of the heartbeat. It also indicates rate of heartbeat. So that's my ECG, right? Now, so as we said that ECG is nothing but it is a graphical record of the electrical variations produced by the beating of the heart during the systole and the diastole, right? It is a graphical record of electrical variations produced by beating of heart during systole and diastole. Fine, do we get this in here? Now, the heart muscle, as we know, generates electrical impulses in the form of depolarization and repolarization. Now, these electrical impulses which are produced by the heart are transmitted throughout the body, right? And these can be recorded by a galvanometer and can be plotted on the graph paper. This graph provides vital information about the rate and the rhythm of the heart and the condition of the heart muscle. Fine, do you get this in here? So how is it recorded? I can say that heart muscle produces electrical impulses. Heart muscle produces electrical impulses in the form of, I'll show you these waves. What is depolarization and repolarization? I'll draw it and show it to you. Give me 2 minutes. Just let me just write this down. Heart muscle produces electrical impulses in the form of depolarization and repolarization that are transmitted throughout the body. These are recorded by galvanometer. These are recorded by galvanometer and can be plotted on the graph paper. Fine. Now, this graph provides vital information about the rate and the rhythm of heart. I think I already told you this, right? The normal electrocardiogram is composed of 4 types of waves, which is called as the P wave, the QRS complex, and the T wave. 3 types of waves. Sorry, I can say a normal I'll draw it and show it to you. A normal electrocardiogram is composed of P wave, QRS complex and T wave, right? This is completed in a cardiac cycle and then repeated again. This is completed in a cardiac cycle. Fine. Now let's try to understand. So this was ECG. Now let's try to see how the wave is. Right? You would have something like this. Right? So this is how it is going to be. This is called as my P wave. This is your QRS complex and this is your T wave. Now let's try to understand each one of them. So the ECG, as you can see, is made up of the P wave, the QRS complex and the T wave. It can be described as a horizontal segment preceding the P wave is designated as the baseline. So this is called as your baseline. The horizontal wave before the P wave is called as the baseline. It is also called as the isopotential line. This is also called as the isopotential line. So the horizontal line before the P wave is called as the baseline or the isopotential line. Now what is the P wave? The P wave, it represents an impulse generated by the sinoatrial node which causes atrial contraction. Depolarization means contraction. So what does the P wave indicate? It indicates the depolarization of SA node. Depolarization means contraction of the SA node. The interval PQ, guys, in the wave, the interval PQ represents the atrial contraction, which should be approximately 0.1 second. Right? So I can say that P wave represents the impulse generated by the sinoatrial node, SA node, which causes atrial depolarization. Depolarization means contraction, which causes atrial depolarization, right? The interval PQ represents atrial contraction on the time scale. The interval PQ represents atrial. The interval PQ represents atrial contraction.
We can write atrial systole.
Yeah, atrial systole also you can write that. Atrial contraction of 0.1 second. So that was my P wave. Now let's try to understand the QRS complex. Right? It represents the spread of the impulse of contraction from the AV node through the bundle of His fibers and the Purkinje fibers to the walls of the ventricles, causing ventricular depolarization. So that QRS indicates that the impulse is spreading from the AV node to the bundle of His fibers to the Purkinje fibers, which causes your ventricular depolarization, and the entire time interval for this should be 0.3 seconds, right? So I can say that the QRS complex represents the spread of impulse of contraction from AV node through his and Purkinje.
So what's his?
His fibers and Purkinje fibers. Remember we did this in the previous lecture. Bundle of his fibers. Those are those vertical bundles. His Sawara. Yeah, those are your his Sawaras, his fibers. Right? Purkinje fibers in the walls of ventricles causing ventricular depolarization. Resulting in ventricular contraction. Resulting in ventricular contraction, which is 0.3 seconds. So that was my QRS complex. Now coming to the T wave. Now the T wave represents ventricular relaxation, which is developed due to the ventricular repolarization. Right? The T wave is the broadest and is completed in 0.2 seconds. Right? So you have first you have the auricular systole, ventricular systole, and then you have the combined diastole, right? So that is your T wave that indicates your combined diastole. So I can say that the T wave represents ventricular relaxation developed due to ventricular repolarization. Right? T wave is the broadest. T wave is the broadest and completed in 0.2 seconds. Right? Thus, in the ECG, the depolarization and repolarization are indicated in the PQRST wave. P, R and T present above the baseline in ECG are called as positive waves, whereas Q and S, which are below the baseline, are called as the negative wave. I can say that P, R and T present above baseline are called positive waves, and Q and S present below baseline are called negative waves. Fine, do we get this in here? Okay, we'll stop this here for the day. Thank you very much.